We, the students of DJ Sangvi College of Engineering within Electronics Department, have made this project called Gesture Capturing and Translation System. Inability to hear and speak is considered to be a true disability. People with disabilities communicate with each other using sign language. In sign language communication, each word is communicated through hand gestures and facial expressions. The main aim of the gesture capturing and translating system is to accurately interpret sign language and convert it into text, thereby developing a mode of communication for the deaf and mute people who primarily rely on text, thus making them feel independent, confident, and creating more opportunities for them to work in a professional setting. This project is divided into three stages: data collection, testing, and training. The collection of data in the form of images is done by using OpenCV. We collect the images from the webcam and create the directory. The folder structure has two files: test data and train data. After the directory is created, each gesture captured will be stored into the corresponding test and train folder. The greater the number of test and train data, the better is the accuracy. A dictionary is created that goes through the directories and counts the number of images that are already stored in the directory, that is in the test and train folder. The count is printed on the screen. Then a region of interest is defined. The ROI created is a rectangle of 64 by 64 size. The RGB image captured is converted into binary image, which is a black and white image, and thresholding is done in such a way that in a matrix of values 0 to 255, any value between 120 to 255 is set to 1 and else is set to 0. On pressing the assigned key on keyboard, an interrupt is created. It captures the image and stores it into the corresponding folder. Now we'll have a look at the directory that we created. It has two folders: test data and train data. Now when we open the folder, we see that only the gestures which were in the region of interest that was created have been captured, and the images has been converted from RGB to black and white, and even the thresholding is done.
After the data is collected, it needs to be pre-processed and only then it can be trained. The number of layers present in the deep neural network are its only distinguishing factor. That is, for the network to be more deep and intricate, there have to be a higher number of layers present. The steps involved in training of a database are: firstly, we need to build a convolutional neural network and add layers to it. The layers which need to be added are a convolution layer, a max pooling layer, and a fully connected layer. In a convolution layer, we specify the number of filters and the size and shape of the convolution window. The main task of the convolution layer and the max pooling layer is to extract the features from the images which have been created. Once this is done, we move on to the second step, which is the actual training, wherein the images which have been collected are fed to the neural network which has been created in the first step. After this, the third step would be to train the model, wherein we specify the number of epochs, the number of steps in each epoch, which translates to the number of images in each of the training set. So as we can see that before we develop an algorithm to train a network, the number of layers must be specified. But this is not always possible in case of huge data sets with a large number of variable factors. This drawback can, however, be overcome using the process of backpropagation, wherein even without sorting the classifiers, the information can be collected and the representation for the recognition can be found. Thus, we can see that training typically consists of two phases. The first is the forward phase, where the information, the input which is collected, is completely passed to the network, and the second is a backward phase, where the gradients are backpropagated and the weights are updated.
After the training comes the actual prediction testing. We use Keras and TensorFlow to predict the gestures. Firstly, we'll load the saved train model and in real time capture our video through the webcam, and a region of interest is created in the specified rectangle as the same during the data collection model. The ROI is converted from a RGB image to a grayscale image, and the gesture from the ROI is matched with the trained model images. When we get a match, the text of the respective gestures is displayed on the screen. Here we can see that the gesture done in the ROI is the same as the prediction, therefore the trained model is working accurately. Further, we will see the prediction on Raspberry Pi. Here is the image we have captured and will read into the code. When we run the code, a frame and an ROI in the grayscale is displayed along with the correct gesture prediction on the left hand side of the ROI.